So now the next thing we're going to do is kind of related to that idea of when you can and when you can't take a root of a negative number, because we're going to look at an example of an even root function. So we're going to graph a square root function, and we're also going to look at what an odd root function looks like. So the first thing we're going to look at is f of x is equal to the square root of x. So this is our base square root function. The first thing I have to ask you is, are there any restrictions in the domain? Meaning, are there any restrictions on x? Is there anything you can't take the square root of? Well, in the previous lesson, we decided that we cannot take an even root of a negative number. So for this one, I cannot take a square root of a negative number, which means that the x value that I choose has to be something greater than or equal to 0. So I can take the square root of 0, right? So if I put in x is 0, I would get y equals, because remember f of x is just y, the square root of 0, which is just 0. So I'm going to pick values of x that are greater than 0. So let's pick 0, let's pick 1. If I put in x is 1, I get the square root of 1, which is 1. Now, here's my question. Should I pick 2? If I plug in 2, y would equal the square root of 2. Well, if I plug into my calculator the square root of 2, I get 1.4142135562. I don't want to graph that. So I'm going to skip 2 and I'm going to skip 3. Actually, I'm going to go to my next perfect square. So after, factoring differences of squares, you should be really good at all your squares. So my perfect squares are 0, 1, and then 4, and then 9. So not that I can't use 2 and 3 and 5 and 6 and 7 and 8, it's that I don't want to, right? I don't want to graph a decimal. So I'm going to pick my next value as x is equal to 4, so that the square root of 4 is 2. And then lastly, I'm going to pick x is 9, because the square root of 9 is 3. And then I'm going to graph this. So I'm going to use a point 0, 0, 1, 1, 4, 2, and 9, 3. And this is going to be what we call our base square root of x function. This is what all the graphs that we make are going to look like when they're a square root of x graph. What's the domain? Well, the domain of this function is actually what we wrote here, right? The restrictions in your domain are the domain. It's the fact that x has to be something greater than or equal to 0, which is that in set notation. Or if you like interval notation, you could put square bracket 0 to infinity round bracket. Then when we look at the range, because my x was restricted, my y is restricted as well. The y values, because it starts at square root of 0, which is 0, my y values also start at 0. So it's my y values are greater than or equal to 0, or square bracket 0 to infinity round bracket. Okay, so we're going to keep this in mind. When you graph a y equals the square root of x graph, you're going to use the x values 0, 1, 4, 9. We're going to look to see if anything will change that. So let's graph the next one. In this next graph, I am going to be graphing y equals the square root of x plus 4. Are there any restrictions on the domain? So again, the restrictions are the fact that you can't take the square root of a negative number. So again, we only have an x under here. So the x value that we choose has to be greater than or equal to 0. So I'm going to pick 0, I'm going to pick 1, 4, and 9. Nothing has changed in my x values. But let's see what happens when we plug those values in for x. I would end up with y equals the square root of 0 plus 4. So now when I take the square root of 0, I get 0, and then if I add 4, I get 4. Let's plug in 1. If y equals the square root of 1 plus 4, all of a sudden the square root of 1 is 1, but then I'm adding 4 and I'm at 5. The next point is when I plug in x is 4. Square root of 4 plus 4 is going to be, the square root of 4 is 2. 2 plus 4 is 6. And then lastly, when I plug in 9, I've got the square root of 9 plus 4. The square root of 9 is 3. 3 plus 4 is 7. If you notice, there's a pattern in these y values. When we graphed the last one, they went 0, 1, 2, 3. And this one, the only difference is instead of starting at 0, it's starting at 4. and it goes 4, 5, 6, 7. So let's plot these. We've got a point at 0, 4. We've got a point at 1, 5. We've got a point at 4, 6. And we've got a point at 9, 7. How does this graph compare to the graph that we just did? Well, if you treated it like this point here is like the x-axis, you can think of it as 0, 0, 1, 1, 4, 2, 9, 3. That pattern doesn't change. You know, we've got square root of 0, square root of 1, square root of 4, square root of 9. The thing that changed is after I took the square root, I added 4. So all my y values are 4 greater than they were before. In fact, if I drew my original y equals the square root of x graph, we go 0, 0, 1, 1, 4, 2, and 9, 3. You'd notice that every single one of these points has gone up 4. We actually do call this a vertical translation, up 4, and if you take Math 60, instead of doing tables of values, you will actually be doing this to graphs. You'll look at this and go, oh, there's a plus 4 on the end. What's that going to do? It's going to make my graph go up 4. And so if you know the base shape, you can just take that base shape and move it. In Math 11, you do not need to do that, but I do encourage you to start thinking of it, and it can save you a bunch of time as well. So if you don't need the table of values, if you're like, oh, okay, I know what this graph's going to look like, you don't get marked on the table of values. You get marked on whether you can graph it or not. So for this one, the domain of that y equals the square root of x plus 4, because that's the graph that we're talking about here, the domain didn't change. It's still 0 to infinity, or x is greater than or equal to 0. The range, however, has gone up 4. So instead of being 0 to infinity, now it's 4 to infinity. Okay, let's look at another one. If we look at this one, we've got y is equal to the square root of x minus 2. If the last graph, when we added 4, made my graph go up 4, what do we predict is going to happen in this graph? Are you hopefully thinking that it's going to be that same graph but moved down 2? If you don't want to worry about that, you don't have to. What we're going to ask ourselves is, are there any restrictions in the domain? Is the value of x going to change? Well, I'm just taking the square root of x, so again, that x value has to be greater than or equal to 0. So I'm going to plug in 0, 1, 4, 9, and I'm going to look to see what happens to my y values when I do that. Well, I've got y equals the square root of 0 minus 2, so 0 minus 2 is negative 2. I plug in 1. Y equals the square root of 1 minus 2. 1 minus 2 is negative 1. Maybe you get the pattern and you don't need to keep plugging in the values for x. Square root of 4 is 2. 2 minus 2 is 0. My y values always go up by 1. Negative 2, negative 1, 0. I'm guessing my next number is going to be 1. Let's check it. Y equals the square root of 9 minus 2. 3 minus 2 is 1. There's so much patterning in math, which is where rules come up. I know that if there's a minus 2 on the end of an equation, I'm going down 2, but I'm going to graph from the table of values. I have a point at 0, negative 2. If you know the shape, you can go over 1 up 1, over 4 up 2, over 3 up 9, or you just keep plotting points. When x is 1, y is negative 1. When x is 4, y is 0. When x is 9, y is 1. And then I connect the dots. Same shape as I had before, just moved down 2. Has the domain changed? Nope, it's still 0 to infinity. Has the range changed? Yep, it's starting at negative 2 and going to infinity. All right, so now what I would like you to do is try one. So now I've got y equals the square root of x minus 5. Ask yourself the question, are there any restrictions in the domain? Can I still choose 0, 1, 4, 9? What's my graph going to look like? What is this square root of x minus 5 going to do? Okay, so pause the video, give this one a go. Okay, so again, my x values are going to be greater than or equal to 0, so I'm going to pick 0, 1, 4, 9. And if you're thinking about it, probably what's going to come up is that someone's going to change these x values. Then I plug them in for x, I end up with the square root of 0 minus 5. So now I know my y values are going to start at negative 5, negative 5, negative 4, negative 3, negative 2. If you don't see the pattern, just keep plugging them in. Square root of 1 minus 5 is negative 4. Square root of 4 minus 5 is negative 3. Square root of 9 minus 5 is negative 2. Plot your points. You have a point at 0, negative 5. Ooh, this graph went down 5. We have a point at 1, negative 4. We have a point at 4, negative 3. And lastly, we have a point at 9, negative 2. Right? The pattern is from that starting point over 1 up 1, over 4 up 2, over 9 up 3. So you can either be thinking this as a transformation, right, down 5, or you can think, okay, my x values are 0, 1, 4, 9. What are my y values going to be? And just graph it with a table of values. So my domain for this one is still 0 to infinity, and my range this time is negative 5 to infinity. All right, go and practice that part. I want to call these transformations, but that's such a Math 60 word. So just practice this type of graph and then come back and watch the next video where we're going to move it maybe left and right. Awesome.